Hey guys, I was talking to Mr. Wilson after class today, and about something I said in class that we decided should be amended. What I said I'm not sure if I said this to everyone, but I sent this video to everybody, so make sure we're all on the same footing moving forward. What I said in class is that when you cut a spring in half, it does not change the spring constant. Okay, so we need to amend that a little bit because while you have not changed the nature of the spring, you haven't changed the gauge of the wire or how tightly wound the coils are, things like that, you do change how the spring responds in certain situations. So let's go ahead and just take a mass and hang it from our spring here. We'll use some green. Take a mass, we'll hang that mass from our spring. Okay. So Hooke's law tells us that, come on, there we go. Hooke's law tells us that the amount the spring is stretched can be found by taking the spring constant times x. So the spring will be stretched from the equilibrium position some distance x. And we'll make that a little bit longer, just to make it easier on ourselves. Okay, some distance x. All right, now when I cut the spring in half and I hang that same mass from the half of the spring, okay, an interesting thing happens. If we think about the spring as a series of coils, right, and each coil has to support part of the total mass, right? So if you have 10 coils, each coil is only forced to support maybe a tenth of the mass. But now that we've cut the spring in half, we've only got 5 coils to support the mass, which means each coil has to exert twice as much force. Okay, or in other words, is going to provide more resistance to stretching. Okay, so a really interesting thing happens. We get a change in x position that is smaller than what we had initially. So effectively, we have a new value of k for this half of the spring. Okay, so basically it's that the load is now distributed into fewer coils. So each coil is having to do more work, and as they get stretched, right, as each coil individually gets stretched, they provide more resistance than they did before because they weren't being stretched quite as far. Okay, so now each coil might be having to be stretched a little bit farther, and will provide more resistance as a result. Okay, so the thing we're going to carry going forward is that if you cut a spring in half, okay, it gains a new effective spring constant. All right, and we won't do too many problems with this, but it is a good conceptual thing to be aware of, that when you do cut a spring in half, it does have an effect on the spring constant you'd use in the equation, even though you have not actually changed anything about the qualities of the spring other than the length. Okay. So if you need more clarification, we can talk about this in class. But I wanted to make sure to get this out quickly because, well, in particular because the problem out on the whiteboard in the hallway has to do with exactly this idea. And it turns out if you cut the spring in half, the new effective spring constant, okay, so cut in half, okay, the new effective spring constant is 2 times the original spring constant. Okay. All right. So hopefully this clear some things up for you guys, particularly next week as we start to do some more spring problems. This is something you should be aware of. All right. Have a good weekend.